Hey there puzzlers, my name is FLEB, and today we're going to be continuing our intuitive solve of the 4x4x4 Rubik's Cube, hopefully finishing up the last layer. There's essentially two steps left, one of which is to orient and position the corners, and the other is to orient and position the edges. So let's start with the corners. The corners should be exactly the same as in the 3x3x3 Rubik's Cube. I already have one that's in the right place, so I'm just going to use the 3x3x3 algorithm to move the remaining three corners around, so they're in their right positions. That's U, R, U prime, L prime, U, R prime, U prime, L. And with that, all of the corners are in their right positions. We just need to get them into their correct orientation, so the yellow faces are facing up. That's just the same algorithm that it is in the 3x3 case. So I'm just going to do that. And then we'll have the edges left. And the edges are going to be a little bit trickier. So you can see now we have all the corners in the right place. Now we just have to get the edges oriented and positioned correctly, and I think it's going to be very tricky. If you think about the techniques that we originally used on the Rubik's Cube, one of the fundamental techniques was finding a way to swap two pieces in the top layer. And when you did that, you could rotate and then undo the moves, which would redo the swap. And using this, you could create cycles that either moved around pieces or oriented pieces, as long as you could rotate the pieces into each other. But here we have a problem. There are four pieces here that can rotate into each other. Kind of see that green piece goes the way that orange piece is. But there's no way to rotate that red piece to where that orange piece is. So it's almost like we have two different cycles of edges on the top that we can mess around with. So for starters, each of those cycles should have the right number of colors in them. This one has orange, blue, orange, green. So we know we need to get at least a red piece in here. And the other cycle has green, red, red, blue. So an orange and red piece definitely has to switch at some point. I think that with the techniques that I've shown before, I'm going to be able to create an algorithm to rotate around three pieces like this. So the question is, what can I do with that? Well, I need to switch an orange and a red. So if I actually turn this slice like this, switching these two pieces would switch two edges that are on different cycles. It'd be nice if we could also switch over one of these green ones at the same time. So what I'm going to do first is I'm going to permute these three edges here. And I'm going to show you that algorithm as I make it. And what that's going to do is allow me to be able to rotate this slice as well. So let's see here. What I want to do is swap these two pieces. So I'm going to need some notation for this. I'm just going to call, I have no idea what this is standard Rubik's notation, but I'm going to call this big L, little r, and big R, with little r matching big R in terms of rotation, and little l matching big L. Okay, so that would be little l. Let's just take that piece away, so B, little l prime. Now I want to put that piece here, so I can do r prime. We need notation for these four layers too. I'm going to call this little m and that big M. Little m prime R. And now we need to get this piece back into place. That should be little m prime F prime little m F. And that swaps those two pieces and those two pieces only. So the next thing to do is to rotate this so that we swap two other pieces. If we rotate it like this, for instance, and undo all of those moves, then I'll swap these back and fix everything that's on these bottom layers here. Backwards, this algorithm is this, so I just need to apply this backwards. F prime, little m prime, F, M, R prime, M, R, little l, B prime, L. Okay, and what's nice about this now is these two green pieces are separated from each other over here. So that's an algorithm that we can now use for swapping these two. There should be a similar thing on the other side, which should be similar moves. So right now what I could do is I could actually fix the orientation of these, but let's think a little bit more about what we're doing here. As I said before, one of these cycles has 2 oranges and the other has 2 reds. So we'd like to swap an orange and a red piece. If we are able to put this like this, we can swap these 2 pieces. And what it'll do is now this orange, if you think about it, will be in the correct orientation with its yellow part facing up. And so will this yellow and red piece as it goes in there. We need to swap 2 other pieces as well. It would be nice if we could fix these greens while we're at it. These greens currently have the wrong orientation. So I think what I want to do is something like this. Swap these 2, then swap these 2, and then undo those 2 moves. Like that, and like that. What I'm going to do is swap these 2, then rotate this twice, and undo that. So that should be little r prime, b prime, little r, L, big L, little m, L prime, little m, F, M prime, F prime. Okay, now we rotate this twice, 1, 2, and we're going to undo all of those moves. And this is hopefully going to work. That's F, M, F prime, M prime, big L, M prime, big L prime, little r prime, B, little r. 1, 2 undoes the top move that we did before. This undoes that slice turn, and this undoes the other slice turn. And look at that. What we have now are all the pieces oriented correctly. And what's more is I hope we have the right number in each cycle. So orange, green, red, blue. That's good. Orange, green, red, blue. That's good too. Now that we've managed to get all the pieces oriented and also get the right colors and the right cycles, we should be able to use these 2 algorithms to just rotate around 3 pieces at a time and get them all in the right place. So let's start with this cycle here. This 1, 2, 3, 4. If I rotate this around, if we swap these 2 and swap these 2, that'll fix that. So let's do that. So little l, b, little l prime, r prime, m prime, r, m prime, f prime, m, f, 1, 2. Now we're going to swap these back. F prime, little m prime, f, m, r prime, m, r, little l, b prime, big L. And now that cycle, 1, 2, 3, 4 pieces are in place. We just need to fix the remaining one. All that we have left here are these 2 last squares to fix. And you might notice that I'm wearing a different shirt now. That's because it took me about 5 to 6 hours spread out over a couple of days to figure out how to fix this situation. This is an example of a parity situation. I can't actually fix this with the algorithms we came up with before. When we encountered this in a previous video, in the 3x3x3 Fisher Cube video, what we did is we swapped 2 different pieces, and that allowed 2 other pieces somewhere else in the cube to get swapped. But when I tried that with the centers, it didn't seem to work. And my theory is that other pieces, maybe centers up here at the top, are also being swapped around while doing that. But there's another way that I came up with for fixing this. And the idea is to do this. Turn this layer by 1 turn, and then resolve this middle layer such that the green centers are here and everything matches the layers below it. So why would this help? Well, sort of what I'm encountering up here on the top is an impossible situation. We need to be able to switch two pieces, and we can't do that with the standard techniques that we learned on the 3x3x3 Rubik's Cube. All of those techniques involve an even number of moves, because you're doing moves and then reversing them. By making a move like this, that's one move, or an odd number of moves. So if I fix everything here using those techniques that use an even number of moves, I should be in the same situation as before, but with an extra move applied to a layer. It's almost as though the cube has two states, an even and an odd state, and by turning it like this, you move it from one to the other. Now that explanation I just gave may not be 100% correct, because it raises some other questions in my mind. Why does switching the centers not work? Are there two different types of parity, one that you have to switch pieces for and one that you have to turn layers for? One other natural question is, well, if it's a single turn, why not apply that turn to the top layer, so you don't have to resolve that middle layer? This is actually what I tried first, but it turns out that I couldn't get the corners back into place. By turning it like this and trying to put the corners back, I always had 2 that were out of place or 4 that were out of place. By fixing that probably would have fixed the edges, but there's just not enough freedom with the techniques that I know already to solve that. But by turning this layer, I absolutely do have enough freedom, because I have this whole top layer to store pieces in. I'm sure that other puzzles in this journey will also be exhibiting these same sort of characteristics, and I think I'll be able to understand it better at that time. But for now, I'm going to resolve the middle layer. Solving this part uses the same techniques that were shown in the first part of this video for solving the first 3 layers. First, you put all the centers back in, using the top layer to store them. And then you're able to also get the edges in, using an intuitive technique that I developed in the last video. Alright, so now we have a modified top layer. What I'm going to do is I'm going to use the algorithm before I'm going to switch around the positions of these 3 pieces. Okay, so now that green side is complete and we have a few other things to fix around here. What I'm going to do next is use the 3x3x3 algorithm to swap the orientations of these 4 pieces, thinking of each of them as a single piece. Okay. Now I'm going to complete the blue face. I'm going to swap that piece in there and then swap that orange piece down there. Now when you use that 3x3x3 algorithm, the other thing that it does is it actually swaps the positions of the 2 pieces. Because what essentially you're doing is bringing this down as one piece, turning this around, and then putting it back in the other way. So if this red piece starts here during that process, when you do that process it ends up on the other side. So doing that, if we turn this slice so that these 2 are lined up, and perform that orientation step again, this red and this orange piece is going to switch, and this blue piece is going to switch orientation. Let's see that. So the red and the orange piece switched places, the red piece went back to its original place, and the blue piece is switched up. And now we can just use that algorithm one more time and put the rest of the pieces of the cube in place. And hopefully I don't mess this up. And there you have it. All solved. So, what did we learn from this puzzle? Well, we learned a little bit more about parity, although this may not be a full understanding yet. And we also got to see how moving to a larger size introduces some more steps that you have to do. We were able to get the first 3 layers pretty easily, but the 4th layer was quite tricky. Next time, I think we're going to solve the 3x3x5 cuboid. Thank you very much for watching. If you enjoyed this video, consider giving the video a like, subscribing to the channel, or following me on Twitter, @FLEB Puzzles. Thank you once again everyone, and as always, Happy puzzling!